Okay, today we're going to do section 2.4 of Foundations in Pre-Calc 10, the sine and cosine ratios. So we're just going to look at what the ratios are, some other ratios in the triangle. We've done tangent, which was opposite over adjacent, and now we're going to do sine and cos, although we're not calling them that on this page. So let's look at triangle ABC, which I'm going to highlight in yellow. So there's A, B, C. Back to A again. The hypotenuse of this triangle is 5 units long. The side opposite angle A, there's angle A, the side opposite is 3. The side adjacent is 4. So if we look at some ratios here, the side opposite angle A to the hypotenuse is 3 over 5, which is 0.6. And the side adjacent to angle A to the hypotenuse is 4 over 5, which is 0.8. Let's look at the next triangle, ADE. We'll go from A to D to E, back to A again. And this one, the hypotenuse is 10. 5 and 5 is 10. The side opposite is 6. The side adjacent is 8 because there's 2 4s. So the ratio of opposite to hypotenuse is 6 over 10, which is 3 over 5, which is 0.6. And the side adjacent to the hypotenuse is 8 over 10, which equals 4 over 5, which is 0.8. Are we seeing a pattern here? I'm going to get you to do the next two triangles while I will do this, but I'm not going to talk. So you do AFG. So you'll see that because these are all similar triangles, the ratios are the same, no matter which of the triangles you want, because the angle is the same. The angle we're talking about, angle A, the ratio of opposite to hypotenuse is always the same, and the ratio of adjacent to hypotenuse is always the same. And so the ratio of opposite to hypotenuse we call sine. Where's my pen? This is the sine ratio, and this is the cosine ratio. And just like the tangent, they're the same for any right triangle with that given angle in it, for that angle. Okay, let's go to the next page. So let's define this. The sine ratio, if angle A is an acute angle in a right triangle, meaning it doesn't work for the right angle, then sine A equals the length of side opposite angle A to the length of the hypotenuse. And the cosine ratio, if angle A is an acute angle in a right triangle, then cosine A is the length of the side adjacent to angle A to the length of hypotenuse. And there's a thing you may have heard. This is how we remember this. It's so katoa. So the best way to write this is that's so katoa. That's a reminder that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There are times when you write it like this, though, just so katoa. You will decide which is the best way for you to write it. And just like with tangent, if we know what the angle is, we can look it up in a table and find the sine, or we can use the sine button or cosine button on our calculator to find it. So we're going to do that now. So if angle A equals 57 degrees, find the sine of angle A. So we're going to go sine of A equals sine 57 degrees. So sine A equals, now on my calculator, the buttons I press are sine 5, 7, enter, equals. Some calculators you would need to put the 5 and the 7 and then hit the sign button. Usually if that's the case, you don't have an equal sign. But you need to check your calculator. Okay, so in this case I go sine 5, 7 equals, and I get an answer that sine A equals 0.8387. And generally, if it doesn't specify how many decimal places, I would suggest you go to 3 decimal places. 2 just doesn't seem to be enough most of the time. If you're going to use it, it doesn't give you a precise enough answer. Okay, let's do an example 2 where we find the cosine of an angle. So angle B is 57. We're using the same angle. So this time we're going to go find the cos of B equals the cos of 57. So cos B equals 0.54469. So cos B 0.545. Now, make sure you do it's the same sequence of buttons. Just use the cos button instead of the sine button, but you do it the same place, same way. Make sure you're getting those answers. If you're not getting those answers, you might need to reset the mode in your calculator. It could be in radians or gradians. You need it to be in degrees. So if you're not getting these numbers, come find me and I'll help you with that. Figure out how to fix your calculator, put it back in the right mode. Okay, let's do this. Finding the sine and cosine of an unknown angle. So this is triangle GHI. Identify the side opposite angle G and the side adjacent to angle G. So there's G, so this is the opposite, and this is the adjacent, and this is the hypotenuse. Find the sine of G and cos of G. So I, just like we did with tan, I like to write it as sine theta equals opposite over hypotenuse. Using theta, just as this is my base equation, and it's always a good idea to write out the base equation. So now I'm going to plug in what I'm actually doing in this circumstances. So sine G equals 8 over 17. And then my calculator tells me that's 0.47. So sine G equals 0.47. Okay, so now I'm going to do cos, so I'm going to go cos theta equals adjacent over hypotenuse. Cosine of G is 15 over 17. So cos G equals 0.88. And then we can use cosine or sine to find the measure of an angle. So now this is where, here's the trick. To figure out whether you're going to use sine or cosine to find what you're looking for. So here's what I do. I write out, we're going to do angle K first. Okay, so I write out so ka toa. And I know some of you are going to fight me on this, that this is too much work, but I'm telling you it makes things a lot easier for you. So I'm going to circle what I know. Circle what I know. Box what I want. So I'm talking about angle K. So I know my hypotenuse, so I'm going to circle my hypotenuse, circle the H for hypotenuse. And I know the opposite. And I'm looking for the angle, which means I'm actually with this equation looking for the sine, the cos, or the tangent. So I'm going to box the sine, the cos, and the tangent, because that's, I need to find that, and then I use my calculator to find the angle. So notice that all three things are marked in this one. That means I'm going to use sine. So I'm going to go sine theta equals opposite over hypotenuse, and then I plug in my values. Sine K equals 3 over 8, and then I do sine to the minus 1 of that side and sine to the minus 1 of that side, and I have K equals. Now I'm just going to put the buttons that you need to push for on the TI calculator. You go second sine. That's what gets you the sine to the minus 1. And then that puts up a bracket, so you go 3 divided by 8. And then you really should put in a closed bracket. You don't have to, but it's a good habit to do that. And then equals. And that will give you K equals 22.0 degrees. And then we need to do angle M. And I'll do the so ka toa again. So for angle M this time, I know the hypotenuse. I'll do this in red again. I know the hypotenuse. Oops, circling that one. I know the hypotenuse. And I know the adjacent, so I'm going to circle the adjacent. And I'm looking for either the tan or the cos or the sine. So I'm going to use cosine this time. So cos theta, so ka is adjacent over hypotenuse. So cos of M equals 3 over 8. Cos to the minus 1, cos to the minus 1. M equals 67.976. And they asked for it to the nearest tenth of a degree, so that is actually 68.0 degrees. Okay, One last step, I need to go DIMS. I need to go, does this make sense? Does that look like it's about a 70-degree angle and that about a 22-degree angle? Yes, it does. I can live with that. Okay? Okay, let's do example 5, using sine or cosine to solve a problem. Sorry. An observer is sitting on a dock watching a float plane in Vancouver Harbor. At a certain time, the plane is 300 meters above the water and 430 meters from the observer. So we need to draw that picture. So the plane is 300 meters high and 430 meters from the observer. Here is the right angle. Determine the angle of elevation of the plane measured from the observer to the nearest degree. So we're looking for this angle of elevation, which I will call theta. Okay, we're going to use our writing out SOHCAHTOA thing. So there's SOHCAHTOA. We're asked to find the angle, which means we need to find either sine or cos or tan. Any of those will do, and then we just work backwards to get the angle. And for angle theta, we know the opposite and the hypotenuse. So let's circle opposite and circle hypotenuse and hypotenuse. And so is the only one that's filled in, so we're going to use sine to solve this problem. So we can write sine theta equals opposite over hypotenuse. Sine theta, we can just leave it as theta, we don't need to name it anything else, equals 300 over 430. So sine theta equals, now last time I put the numbers into the sine, this time I'm going to go figure out what that value is, 300 divided by 430, which is 0.69767. Now, it's important that if you do it this way and you do this calculation and then do the inverse sine on both sides, that you keep all of those digits in the calculator. Even though you might not write them all down, you need to keep them all there. You only round when you get to the last step of the when you're writing out the answer. So now we'll go second sine, second answer. And I get theta equals 44.24, and it asks to the nearest degree, so theta equals 44 degrees. Okay, that's it.